In these problems, we're finding the critical z-values, and we have to take into account what type of test we're doing. So in number 11, we're doing a two-tailed test. So what I'm going to do is draw my distribution, and alpha is 0.01. Since it's a two-tailed test, that means we're splitting alpha between the two tails. So this tail is 0.005, and this tail is 0.005. And 0.005. So I get that by taking the 0.01 and dividing by 2. So now, because it's a two-tailed test again, we're going to need one positive answer and one negative answer. So I'm going to enter inverse norm into my calculator, 0.005. Now, if the calculator requires you to give the mean and standard deviation, you give 0 and 1. Everybody else can just use inverse norm 0.005, and the default is 0, 1. And when we put that into the calculator, let's see what we get. Then we get negative 2.58, rounded to 2 decimal places. And because, again, it's a two-tailed test, so our answer is plus or minus 2.58, because we have one positive and one negative. We don't need to recalculate to get the positive answer because the number value will be the same. So that's my final answer for that. In number 12, we are doing a right tail test. So all of the alpha is in the right tail, 0.01. So I'll do inverse norm of 0.01. Now this is going to give me a negative answer, and on a right tail test I should have a positive critical value. So all I have to do is just take the negative off once I find this. So this is negative 2.33. So for my answer I'll just say positive 2.33, and that's my answer for 12. And then in 13, it's a left tail test, and we have 0.02 in the left tail. So again, inverse norm, and now it's of 0.02, and that turns out to be negative 2.05. Now in a left tail test you should have a negative solution, so we have negative 2.05, and that's the answer for that.